Hello and hi everyone. So this is our project assignment for BET 2333 Communication Principle with the title of the project PCM, which is Passcode Modulation. So what is PCM? Based on Wikipedia, PCM is a method used to digitally represent sample analog signals. It is the standard form of digital audio in computers, compact disc, digital telephony, and other digital audio applications. In other words, PCM is essentially analog to digital conversion of a special type where the information contained in the instantaneous samples of an analog signal is represented by digital words in a serial bit stream. So for the objective is to understand one of digital modulation technique to generate the passcode modulation PCM signal using MATLAB, and to plot the passcode modulation signal using MATLAB. The advantage of PCM is it's convenient for long distance communication. Secondly, PCM has higher transmitter efficiency, and lastly, it has higher noise immunity. For this advantage, the passcode modulation PCM requires large bandwidth as compared to analog system, and its encoding, decoding, and quantizing circuit of PCM is very complex.
Okay, from question 1, we went to search about the frequency of the analog signal at the beginning of, for example 1, use example 1. Okay, for the MATLAB, this coding of MATLAB for example 1. Okay, close all ni for use to clear MATLAB window, and this use function used to plot graph, to plot sine wave by using the formula and condition to create array of the or zero with fixed point properties. This is a polynomial evaluation. Okay, for this coding is for label for window output windows for graph figure 1, and subplot position by row the first subplot in the first column of the first row, and the second subplot is for second column and first row, and so on. Okay, so polynomial evaluation to plot this axis, title of graph, x axis label and y axis label for this label. Okay, so for this n equal to 3 is assign value of n, equatize and encode floating points input to integrate outputs. Okay, for this anti-title figure 2 is to use to label of output window for figure 2. Subplot position by row the first subplot in the first row of the first row, and second subplot is the second column of the first row. So this to label plot axis, title, and x axis and y axis. Okay, the last coding is this subplot 212 plot R is label for output windows for graph 3. Plotting label x and y axis and for digital signal process. Okay, from the coding, we run the coding to we get figure. The figure for the first figure is analog signal, and second signal is analog signal. Okay, so the third and fourth signal is encoded signal and decoded signal, and the period we get is 100. Okay, the figure 3 is square signal for the example 1. Okay, To get the frequency of this coding, okay, first we search for the period. Is the period for the circuit is 100, and frequency, the formula of frequency is frequency equal to 1 over period, and the period is frequency is 1 over period. Period is 100, and we get the frequency is 0.001 Hz. So for the question 1, the frequency is 0.001 Hz. Okay, the question 2 is the generate a 2 kHz sinusoidal with a peak to peak voltage of 2 volt and generate a quantized signal when 1.8 and 1 and equal to 16 levels, and then we calculate the signal to quantization noise ratio. Okay, this is the formula of to get the SQNR. Okay, the first for n equal to 8 and the smaller n equal to 3. Dynamic range is 20 log 2 power of 3, and we get the answer is 18.06 dB. Okay, to Sn is 1.76 plus 18.06, and we get 19.82 dB. Okay, for the answer, SQNR is 10 log 3 divided by 64. So we get 22.83 dB. Okay, for the second, we search for n equal to 16 and smallest n is 4, and the dynamic range is 20 log 2 power of 4. Then the result is 24.08 dB. For Sn equal to 1.76 plus 24.08, and we get 24.84 dB. So the final is 10 log 3 multiplied by 16 power of 2, and the answer is 28.85 dB. So the 1.76 we get from the first operation research is constant value. Okay, this is coding MATLAB for question 2. Okay, this is MATLAB. Okay, so we get this MATLAB. So for this, t equal to 0, 0.1 and 5 is the use to plot the time and the equation for signal output and message signal. For this we use to for the signal to be compressed by using the mu law of one way of quantization. Use value 255, which is maximum value of the signal. So this is used to plot the graph, to plot x-axis and y-axis. Okay, for the this use encoding and decoding. Okay, this plot graph, plot figure. Okay, so from the coding we get the graph of example 2, and we get two graph for n equal to 8 and n equal to 16. So from the graph we get the difference of amplitude. For the last question is use the MATLAB Simulink for the question 1 and question 2. Okay, so this is Simulink block diagram for question 2. So this is the block diagram of Simulink for question 2. Okay, so from this block diagram we get the Simulink output n equals to 8, and after we convert to n equal to 60, we get the Simulink graph of Simulink this.
Next, we go to the discussion. From our discussion, we need to be complete the assignment title passcode modulation (PSN). Below we show our discussion. Firstly, students have studied about the passcode modulation (PCN) signal using MATLAB. Second, students have constructed coding using MATLAB, and automatically the signal waveform will pull up at common window. After that, students have plot by using subplot or plot, and automatically the graph will pull up. The result they shown at the above. Next, we go to the conclusion. At the end of the assignment, we need to be complete to ensure we have achieved our goal and show that the assignment is successful. Firstly, we learn on how to understand one of digital modulation technique. Next, we were able to generate the passcode modulation PSN signal using MATLAB. After getting coding, we'll also plot the passcode modulation signal using MATLAB, and automatically the graph will pull up. Moreover, all the tasks given is complete, and we'll also achieve all the objectives needed in this assignment. Thank you.
Okay, that's all for our project assignment for DEET 2333 Communication Principle. Thank you.